AP Chemistry Chapter 3 Lesson Video Part 2. And so today we're going to focus on Section 3.4. The good news is you've already learned all of this information from Honors Chemistry. So again, this should just be a review. So let's go ahead and get started. So Section 3.4 is about Avogadro's number and the mole. So both of those should sound very familiar. So in chemistry, the unit for dealing with the number of atoms, ions, or molecules in a common size sample is the mole, which is abbreviated MOL. And 1 mole, as you should already know, is 6.02 times 10 to the 23 representative particles. And so those representative particles can be atoms, molecules, ions, it's just whatever the question's talking about. Whoop, already got my answer up there. Hopefully you didn't see that. Alright, so it says arrange the following samples in order of increasing number of carbon atoms. So there's many different ways that you can do this. Okay, so what I'm going to do is I'm just going to base it on moles. So 12 grams of carbon 12 is 1 mole because the mass of carbon is 12. So this right here is equivalent to 1 mole of carbon. This one says 1 mole of C2H2. So you might be quick to think, oh, well, that's 1 mole of carbon also. But it has a 2. So in C2H2, there's actually 2 moles of carbon. So you have to keep in mind those subscripts. That's going to increase the amount of carbon. Then it says 9 times 10 to the 23 molecules of CO2. Well, I know that 1 mole is 6.02 times 10 to the 23 molecules. And so 9 times 10 to the 23 molecules is about 1.5 moles. And because it's just CO2, that means I don't need to multiply by a subscript. So once I know this, it says arrange them in order of increasing numbers of carbon atoms. Well, I would start with my 12 grams of C12. That would be my lowest, 1 mole. Then I would do my 9 times 10 to the 23 molecules of CO2, because that's 1.5 moles. And last, I would end with my 1 mole of C2H2. So the thing you got to be careful of is when it has a subscript. You got to be careful and make sure you include that. Just like we did when we would do percent composition. We would take into account how many we have. So in this case, instead of going to moles, what I did was I went to molecules. And so I said, okay, well 12 grams is 1 mole, so that's 6.02 times 10 to the 23 atoms of carbon. 9 times 10 to the 23 molecules is 9 times 10 to the 23 atoms of carbon. And 1 mole of C2H2 has 2 times 6.02 times 10 to the 23 carbon atoms. So that's how I did it on here. So same method, just a little bit different way of getting there. So maybe try this one on your own real quick and then we'll look at it together. So it says arrange the following samples in order of increasing number of oxygen atoms. Okay, so I can see 1 mole of H2O, so there's only 1 O, so I know, okay, well this is going to be 1 mole of oxygen. We have 1 mole, sorry, my 1's over here, 1 mole of CO2. So again, even though it seems like it's 1 mole, we're getting 2 oxygens for this one. So this is actually 2 moles of oxygen. And then last is 3 times 10 to the 23 molecules of O3. Well, I know 1 mole is about 6 times 10 to the 23. So this would actually be 0.5 moles. However, I get 3 oxygens from it. So 0.5 times 3 is 1.5 moles. So once I know how to compare them all with moles, I can see that the lowest amount would be the water, second would be the O3, and the highest amount of oxygen would be the CO2. Alright, so hopefully that wasn't that difficult. Just like I said, make sure you pay attention to subscripts. And so again on here, all I did was change it to atoms instead of moles. Either way works. Alright, so it says calculate the number of hydrogen atoms in 0.35 moles of C6H12O6. Okay, well as always we start with what we know. So we know we have 0.35 moles of C6H12O6. I'm trying to get to hydrogen atoms. So I can see that 1 mole of C6H12O6 has 12 moles of hydrogen. So that's 12 moles of hydrogen in that molecule. But we're looking for number of atoms, so I need to go from moles to atoms. So I know 1 mole of hydrogen is 6.02 times 10 to the 23 atoms of hydrogen. See y'all, it's all just a canceling game. We're trying to get to the unit they asked for. Alright, so in this case, once I multiplied everything, I got 2.53 times 10 to the 24 atoms of hydrogen. Okay, and some of you may be wondering, it says hydrogen is diatomic, why did I not put the 2? Well, remember, it's not by itself here. We're pulling it out of a compound. Okay, so it's not in its elemental form. So that's why you'll notice I left off the 2 there. Alright, so let's look at another one. Maybe you try the next one, pause the video, try it, make sure you can get it. Alright, so it says how many oxygen atoms are in 0.25 moles of calcium nitrate? Well, the first thing I need to do is write that formula. So calcium Ca, I don't see any prefixes, so I need to put the charge, positive 2. Nitrates, NO3, negative 1. So I need 2 nitrates. So there's my formula. So we're starting with 0.25 moles of calcium nitrate. But we're trying to get to oxygen atoms. We're not worried about the calcium or the nitrogen. Okay, so I can see 1 mole of calcium nitrate is how many oxygens? Remember, we multiply, don't add. 6 moles of oxygen. Alright, so we're looking for atoms though, not moles, so I need to do that last step I just did where I said 1 mole oxygen is 6.02 times 10 to the 23 atoms of oxygen, just like that. So I made it to atoms of oxygen. Remember, although it's diatomic, it's in a compound, so we're just going to put oxygen as our unit. So once I multiplied across the top, I got 9.03 times 10 to the 23 atoms of oxygen. So hopefully you got that one right. If not, a lot of times you miss the formula. It's not the math that gets y'all, it's writing the formula. Alright, so next one, it says we have 1.5 moles of sodium carbonate. So again, I need to start by writing my formula. So sodium is Na, it has a positive 1 charge. Carbonate is CO3 and it's a negative 2 charge. So I need 2 sodium, just like that. Alright, so I start with what I know. I have 1.5 moles of sodium carbonate. So my first step is, remember, I'm trying to get to oxygen, not sodium carbonate. So I can see 1 mole of sodium carbonate is 3 moles of oxygen. Remember, it's using that subscript. Alright, but of course it asks me for atoms, not moles. So I have to do my last step of using Avogadro's number. So 1 mole of oxygen is 6.02 times 10 to the 23 atoms of oxygen. So once I multiply across the top, I end up getting 2.71 times 10 to the 24 atoms of oxygen. Okay, so all we're doing is just basic conversions. It's just we're pulling one element out of a compound. Okay, so nothing weird or hard there, hopefully. So let's move on to something else that you've already learned, because we already learned how to do mole conversions in honors. Something else you've already learned is molar mass. So in one of our previous videos, we did formula weight, and we were using the unit AMU, which is atomic mass unit. When we're talking about molar mass, it's the mass of 1 mole of that substance. And so in that case, we can change our unit to grams per mole. So a mole is always the same number, 6.02 times 10 to the 23. But 1 mole sample of different substances will have different masses because elements all have different masses. The mass of a single atom of an element in AMU is numerically equal to the mass in grams of 1 mole of that element. So 1 carbon atom may have a mass of 12 AMU. 1 mole of carbon has a mass of 12 grams. And so as you can imagine, in lab, we like to use grams more because that's what most of our scales measure. And plus, we're not working with 1 atom at a time in lab. So the mass in grams of 1 mole of a substance is called molar mass. So again, this is total review, so we're going to go through this quickly. So it says, what is the mass in grams of 1 mole of glucose? Okay, well it's asking me for 1 mole, so I don't need to do anything with that because we know that molar mass is grams per mole. So I just need to add up. Now this is the last time in the videos that I'm going to actually show you how to do molar mass. From now on, once we hit the stoichiometry in just a few videos, or it may even be the next one, I'm just going to put the molar mass up, okay? You've got to be able to do that on your own. We don't have time for me to add up the molar mass every single time. All right, so my mass of carbon's 12, but I'm going to multiply it by 6 because I have 6 carbons. My mass of hydrogen's 1, but I'm going to multiply it by 12 because I have 12 hydrogens. My mass of oxygen is 16, but I'm going to multiply it by 6 because I have 6 oxygens. You really need to get to where you can literally just type this in the calculator. You don't even want to have to write this out. Okay, and so what that gives me is 180 grams per mole. But notice it asks me how many grams in 1 mole. Well, grams per mole means how many in 1 mole, so my answer would be 180 grams. Okay, because remember, I like to beat in your mind that the unit of molar mass is grams per mole, but because this one asks for the grams in 1 mole, that's why I have just reduced my units to just grams. All right, so hopefully that was super easy. It always is, especially when they give you the formula. The problem is when you don't get the formula. All right, so like for this one, remember, make sure you're trying some of these. It says calculate the molar mass of calcium nitrate. Wow, they really like using calcium nitrate as a sample in this book. I feel like we've done this one a million times. So calcium has a 2 positive charge. Nitrate is, of course, -1, so I need 2 nitrates. All right, so let's add up the molar mass. So calcium is about 40. I just have 1 calcium. Nitrogen is about 14, but I have 2 nitrogens. And then oxygen is 16, but I have 6 oxygens. So once I add and multiply all of that, I get about 164 grams per mole. Just like that. And so again, the main thing that y'all usually miss on molar mass is not adding up the molar mass. The math is the part you're good at. It's writing the formula. So you really got to get good at writing the formulas. All right, so remember, make sure you're trying some of these on your own. So it says calculate the number of moles of glucose in 5.38 grams of glucose. Okay, so we have a starting point. We're starting with grams. So we have 5.38 grams of glucose. Glucose is C6H12O6. You should know that from biology. I would just go ahead and memorize that because we do use it a lot in chemistry. All right, so we're trying to get from grams to moles. So we know 1 mole equals molar mass. So I need to add up the molar mass. So this is where I'm not going to write it out anymore. When you add up the molar mass of glucose, you end up getting 180 grams per mole. So I know 180 grams equals 1 mole. So I put the 180 grams on bottom because I needed to cancel, and that equals 1 mole. So see, this is how I'm going to do it from now on. Like, we're just going to say what the molar mass is. We're not going to keep adding it up together. All right, so once I divide my 2 numbers, I get 0.03 moles of glucose. Just like that. And so again, we've done this in honors chemistry plenty of times. So hopefully you're getting all these right. Hopefully you're trying them on your own. All right, so let's look at a few more. So it says, how many moles of sodium bicarbonate are in 508 grams of sodium bicarbonate? So one thing, an older name for the polyatomic ion hydrogen carbonate is bicarbonate. So I'll put this little blurb in there for you. So it's also known as sodium hydrogen carbonate. So if you see bicarbonate, it's just hydrogen carbonate. So first, let's write our formula. So sodium is Na positive. Bicarbonate or hydrogen carbonate is HCO3 negative. So I don't need to do anything to balance my charges. So we're starting with 508 grams of sodium hydrogen carbonate, or bicarbonate. We are trying to get to moles. So that means I need to do molar mass. So again, I'm not going to show you how I've added it up. Hopefully you got that by now. But I get about 84 grams per mole when I add up NaHCO3. So I put my 84 grams on bottom and my 1 mole on top. So my grams cancel. Remember, you're just following the golden rule every single time. You're going to see me do the golden rule 8 billion times during this chapter. All right, so once I divide, I end up getting let's see, whoops, oh, I was looking at the wrong question. 6.05 moles of sodium hydrogen carbonate. There we go. And that's it. That's all you gotta do. Okay, molar mass is super simple as long as you got the right formula. Got the right formula. Gotta make sure you can do the formula. So remember, don't forget to be trying some of these on your own. Okay, so our next one says calculate the mass in grams of 0.433 moles of calcium nitrate. So let's write our formula. See, calcium nitrate again. What in the world? Hopefully you know the formula by now. So calcium is Ca with a positive 2 charge. Nitrate's NO3 negative, so I need 2 nitrates. So I'm going to start with my 0.433 moles of calcium nitrate. I'm trying to get to mass in grams, so I need my molar mass. So when I add up calcium nitrate, I get 164 grams per mole. So this time mole is on top, so I'm going to put the 1 mole on bottom because I'm going to follow the golden rule. Whatever unit is on top, I cancel it by putting it on bottom. That equals 164 grams calcium nitrate. So once I multiply across the top, I get about 71.012 grams of calcium nitrate. Just like that. Okay, so again, hopefully this is all ringing a bell from Honors Chem, because we did this. We pretty much did everything from this whole chapter in Honors Chem. Alright, so make sure you're trying these on your own, okay? And don't forget what I told you about bicarbonate. Alright, so it says, what is the mass in grams of 6.33 moles of sodium bicarbonate? So remember, sodium is Na positive, bicarbonate is hydrogen carbonate, so HCO3 negative. So I start with my 6.33 moles of sodium hydrogen carbonate. So I'm trying to get to grams, so when I add up the molar mass, like we did before, it's 84 grams per mole. So I have mole on top, so I put my 1 mole on bottom, and my 84 grams on top. So that way my moles cancel. So once I multiply the two numbers, I get about 532 grams sodium hydrogen carbonate. Just like that. Okay, so hopefully you tried these and you're getting them right. Alright, so our next one is, what is the mass in grams of 3 times 10 to the negative 5 moles of sulfuric acid? So acids, a lot of y'all have trouble naming those. Remember, if it ends in acid, it starts with hydrogen. Sulfuric comes from sulfate, SO4 negative 2, so I need 2 hydrogens.
Miss Brady, please make contact with the front office.
Alright,
Miss
so
Brady.
I'm going to start with what I know, and that's 3 times 10 to the negative 5 moles of sulfuric acid. We are trying to get to grams. So when I add up my molar mass for sulfuric acid, I get 98 grams per mole. So I have mole on top, so I put my 1 mole of sulfuric acid on bottom, and my 98 grams of sulfuric acid on top. So my moles cancel, and then once I multiply my two numbers, I got 2.94 times 10 to the negative 3 grams of, whoop, I almost put sodium hydrogen carbonate, sulfuric acid. Just like that. Alright, so hopefully you're finding this pretty easy. Okay, so let's look at just a couple more examples. Because again, y'all, it's not just about can you do this problem. Like, you don't want to take 20 minutes to do a problem like this, or you're not going to finish the AP exam. Alright, so we have 2 more slides to look at. Alright, so remember, make sure you're trying some of these. You shouldn't have to wait for me to even do the samples, really, because you should already know how to do this. So it says, how many molecules are in 5.23 grams of glucose? So I'm starting with 5.23 grams of glucose. Remember, I told you glucose is C6H12O6. It has a molar mass of 180 grams per mole. But here's the thing. I know there's 180 grams in a mole. I'm trying to get to molecules. I also know there's 6.02 times 10 to the 23 molecules in 1 mole. So you can actually combine those conversion factors and say, okay, well, 180 grams equals 6.02 times 10 to the 23 molecules. And then you can just do it in 1 step. However, I'll show you if you're like, what the heck, I would have done it in 2 steps. I'll show you how you can do it in 2 steps. I'll show you right underneath. So once I multiplied and divided, I got 1.75 times 10 to the 22 molecules of glucose. So let's say you didn't realize you could combine those two conversion factors. Well, you easily could have just done this instead. It's just an extra step. And remember, we're trying to save time on the AP exam. You could have said 180 grams of C6H12O6 equals 1 mole of C6H12O6. And then you could have said, and 1 mole of my glucose equals 6.02 times 10 to the 23 molecules of the glucose. And so as you can see, the math is the same. See, I'm dividing by 180 and multiplying by 6.02. I'm doing the same thing here, it's just 2 steps instead of 1. Okay, so I like to do 1 step when possible just to save time. Alright, so next it says how many oxygen atoms are in this sample. Well, I can see how many molecules I have, so let's just start with that. Alright, so I started with my 1.75 times 10 to the 22 molecules of C6H12O6. And I'm trying to get to atoms of oxygen. Okay, so I know that 1 molecule of C6H12O6 contains 6 atoms of oxygen. So all I need to do is multiply my number by 6. And when I do that, I get 1.05 times 10 to the 23 atoms of oxygen. Okay, so don't let pulling a single element out of a compound throw you off on these. We did a little bit of that in Honors Chem, but I didn't focus on it a lot, mainly because we were running out of time every day, if y'all remember correctly. Alright, so our last slide. So remember, make sure you're trying these on your own. It's very similar to the one I just showed you. So it says, how many molecules are in 4.2 grams of nitric acid? Well, let me write nitric acid first. If it ends in acid, it starts with hydrogen, which has a positive 1 charge. Nitric came from nitrate, which is NO3 negative, so I don't need to balance my charges. So I start with my 4.2 grams of nitric acid. My molar mass for nitric acid is about 63 grams per mole. So I'll put my 63 grams on bottom. But remember, I'm trying to get to molecules, so I can go ahead and say, okay, well 63 grams equals 6.02 times 10 to the 23 molecules. Again, save yourself a step. So once I multiply and divide, I ended up getting 4.01 times 10 to the 22 molecules of nitric acid. So then our last one is very similar. It says how many oxygen atoms? Okay, well I know I'm starting with this many molecules of nitric acid, which nitric acid isn't really a molecule, it's more like a form in the unit because it's going to separate since this is strong acid. Just throwing that out there. Alright, so I can see that 1 molecule of nitric acid has 3 atoms of oxygen. So then I just multiply my number by 3. Like really, you wouldn't even have to work this out. You can probably just tell that in your mind. Like, hey, there's this many molecules of HNO3 and every single one has 3 oxygens. I need to multiply by 3. Okay, but you know I'm going to show you the actual math behind it. But remember, you're more than welcome to do any of this in your calculator. And so I ended up getting 1.203 times 10 to the 23 atoms of oxygen. Alright, so that was section 3.4. Hopefully it was a little refresher and something that we did in Honors Chem already. And so just know stoichiometry is coming.